Good day, MT1. Welcome to the last part of our Module 3, which is about chemical reactions, calculations, and solutions. This is our third module for MTChem lecture. Let's have a quick run over on our Module 3 outline. We've already finished discussing about chemical equations. We've also finished discussing about chemical calculations wherein you studied or you solved for different problems for formula mass and mole. We'll now proceed with solutions. Solutions, though it has a lot of subtopics, they are generally easy and quick to discuss. So we'll be discussing and tackling about definitions and characteristics, the general properties of solutions, solubility, solubility rules, molarity, concentration, and dilution. For this last three, we will be involving some calculations, so please prepare your scientific calculators and your scratch papers. Let's proceed with our discussion. So what are solutions? Solutions is a homogeneous mixture of two or more substances with each substance retaining its own chemical identity. So when we say retaining, they stay true to their identity, okay, or to their chemical property. Solutions has two components, and that is solvent and solute. Solvent is a component that is present in the greatest amount. Okay, this is the medium that does the dissolving and dissolves the solute. What is a solute, on the other hand? This one is a component that is present in a much lesser amount relative to that of the solvent. This is also the substance to be dissolved. Okay, if you are to compare solvent and solute, in terms of amount, solvent will be the greater one. Okay? Again, solvent is the one that dissolves the solute. Solute is the one that is being dissolved. Say for example in a salt solution. Salt solution contains water and salt. Which of the two do you think is the solvent and which is the solute? By simply looking at our definition, the greatest amount between these two is water, making it the solvent. Our solute here will be salt. Water dissolves salt, making water the solvent and salt the solute. Let's proceed with the general properties of solutions. First, a solution contains two or more components, and those are a solvent and a solute. These are the ones that we mentioned earlier. We have here the salt solution that we mentioned. So you have your salt as the solute and water as your solvent, in making it a salt water solution. Next, a solution has a variable composition. That is, the ratio of solute to solvent may be varied. This means that you can add how much solute and solvent you need to add. Okay? The ratio, or how many solute is comparison to solvent, can be different from time to time. In relation to this, the properties of a solution change as the ratio of solute to solvent is changed. Since the ratio of solvent to solute can be varied, along with this also changes the properties of a solution. Does the solution have more or less solute? Does it have more or less solvent? These types of questions can change the properties of your given solution. The dissolved solutes are present in the individual particles. Step 1. The solutes remain uniformly distributed throughout the solution and will not settle out in time. This means when we say uniformly distributed, they have a single homogeneous appearance. You cannot identify anymore which is the solvent and which is the solute because the particles, okay, these individual particles that we are referring to are uniformly distributed. Last one, the solutes generally can be separated from the solvent by physical means such as evaporation. Let's go back to our salt solution a while ago. If you subject it to a high heat, water will evaporate, leaving salt crystals behind. Let's proceed with the concepts related to solutions. First, we have saturation. When we say saturation, this talks about the ratio between solvent and solute. Let's start with the first one, which is the unsaturated solution. Unsaturated solution is a type of solution that has less solute than the saturated solution. Okay, that completely dissolves, leaving no remaining substances. Again, it's a solution that completely dissolves the solute, leaving no remaining substances. A more solute dissolves. This means that because it has lesser solute and more solvent, which does the dissolving, more solute dissolves. Another type is a saturated solution. A saturated solution is a solution with solute that dissolves until it is unable to dissolve anymore, leaving the undissolved substances at the bottom. With its excess solute, it leaves residue at the bottom of the container. This means that your solvent cannot dissolve any more solute. And then the next one, we have supersaturated solution, in which this is a solution that contains more undissolved solute than the saturated solution because of its tendency to crystallize and precipitate. This one has too much solute added to the solution, making it form crystal. It becomes unstable, so crystals are being formed. So upon seeing crystals at the bottom of the container or upon observing that there is formation of crystals, you already know that the solution is supersaturated. Another concept that we have for the ratio of solute and solvent is dilution. We have here two types of solution, which is what we call dilute and concentrated. First, a dilute solution is a solution that has a small amount of solute in a large amount of solvent. In this one, we have so much solvent and very little solute. As you can see here, the particles, these pink particles are solute and we have a lot of solvent in comparison to the number of solute. Concentrated solution, on the other hand, is the opposite. It has a large amount of solute in a small amount of solvent. Comparing the two, this has larger amount of solute and the same amount of solvent. So this makes this a concentrated solution, making it difficult for it to dissolve the given solute. Next, we also have what we call the aqueous and non-aqueous solutions. You might have encountered this or you might have seen them in chemical equations symbolized as parenthesis AQ, indicating that it's an aqueous solution. So what is an aqueous solution? This is a solution in which water is the solvent. We call water the universal solvent. So we usually use this one to dissolve or to dilute some chemicals. Non-aqueous, on the other hand, with the name itself, meaning it is a solution in which a substance other than water is the solvent. So instead of using water, we use alcohols or even organic compounds. Okay? So in aqueous solution, you have to simply remember it is water And then for non-aqueous solution, any other than water. So it can be alcohols or organic compounds. Let us now proceed with the discussion of solubility and its rules. So what is solubility? Solubility means it's the maximum amount of solute that will dissolve in a given amount of solvent under a given set of conditions. In this one, we follow the principle like dissolves like. Okay? Again, maximum amount of solute that will dissolve in a given amount of solvent under a given set of conditions. Please remember this one too. Like dissolves like. Let's take a look at this table wherein you will see the different compounds that can be dissolved in water. Okay? We have here soluble and insoluble compounds. Let's put these rules into practice. Let's predict the solubility of the following solutes in the solvents indicated. Let's take a look at this table wherein different solvents, solutes are shown. We will be predicting the solubility by putting if it's soluble or insoluble. First, we have water and CH4 or methane gas. We have here water which is considered as polar. And we have here CH4 which is a non-polar. Following the principle of like dissolves like, what do you think will be the solubility of water and CH4? They will be insoluble. Again, polar and non-polar, they are different, so they will be insoluble or this gas will not dissolve in water. Next, we have ethyl alcohol and chloroform. Ethyl alcohol is a polar compound. Chloroform is also a polar compound. Again, following the principle of like dissolves like, what do you think is the solubility of these two compounds? This will be soluble. Okay, following the principle. Next, we have here water and salt or NaCl. Water, again, is polar. NaCl or salt or sodium chloride is also polar, which means that the solubility for this water and salt will be soluble. For the fourth and last one, we have water and MgCO3 or magnesium carbonate. Water is a polar compound. Magnesium carbonate, on the other hand, we have this rule that carbonates are insoluble to any polar compounds. Again, they are insoluble in any polar compounds. So since we have here magnesium carbonate and water, this will be insoluble. Okay, because again, carbonates are insoluble in water. Okay, carbonates are insoluble in any polar compounds. So again, let's take a look at our outline. We've already discussed definitions and characteristics, general properties of solution, solubility, and solubility rules. We'll now proceed with the discussion of molarity, concentration, and dilution. You may take a short break to prepare yourself for the calculation and then you can continue with the next video.